In this video, I'm going to show you how you can quickly and easily make your own indicators for trading with zero experience in programming or math. By the end of this video, you'll be able to come up with ideas and implement them easily using some very basic concepts and by taking advantage of a resource that allows us to do this without any prior math or programming knowledge. We'll have made 3 custom indicators using simple concepts and just a few lines of code. We're going to be using TradingView's Pinescript for this tutorial. It's completely free to sign up and to make and use custom Pinescript indicators. There's a link in the description to sign up if you haven't already. First, we need to open a chart. Start by going to Supercharts. It doesn't matter what security you choose, we just need something to apply the indicator to. At the bottom of the window, you'll see a tab that says Pine Editor. This is where we will make the indicator. Click on it and it will open up in the bottom of the window. To make it easier to work, I'm going to click on the 3 dots in the top right and select Open in New Window. Since my goal is for you to be able to actually create something of your own by the end of this video, I'm going to omit a lot of basic information if it's not absolutely necessary to create an indicator. This is the first video in a series on making your own indicators, and in the future I'll go more in depth and cover the basics of Pinescript and more advanced topics. But I know how boring it can be to learn the basics and still not be able to actually create anything useful with what you've learned. So the primary goal for this video is not to learn the basics of programming or even Pinescript. It's for you to be able to make indicators on your own using some simple building blocks. Okay, let's get started. There's some stuff already here by default when we open the script. Indicator my script and plot close. The top line that says indicator my script will always be here at the top of your code and you won't remove that. But below you'll see plot close. It's actually pretty intuitive what this does. Plot is a function that plots whatever is in the parentheses on our indicator. You can see we have plot close, and close is the closing prices of whatever we have on our chart at that time. So all this line is doing is plotting the close prices. If I go up to the right and click Add to Chart, we can see what this does. It creates our indicator window and just plots all of the close prices. But we actually want to do something with the close prices. We want to use them in our own indicator and then plot our indicator instead. So we're going to get rid of this line. Okay, here's the key to making indicators easily and simply. We're going to use built-in functions where the programming and math is already done for us. But what is a function? Well, it's not complicated. It's something that does the work for us. We simply put in some basic parameters and it gives us the result. For example, we don't need to know anything about how to calculate an exponential moving average to use it. All we need to do is put the length we want just like normal and give a source for it. It's just as simple as applying a regular EMA to your chart. We don't need any more information. Let's do something super basic first, then we'll add on this later to create more powerful indicators. Let's use the function that creates an EMA for us. All the built-in functions start with the same thing, TA and then dot, and then the name of what we want to use. So an EMA would be ta.ema. Now, there's 2 things we need for an EMA. We need the thing we want the EMA of, and then a length for it. This is just like the regular EMA indicator you put on your chart. There's an option for a source, and then an option for the length. To input those into our function, we create parentheses beside it. When I do that, a box comes up that tells us what parameters we need to input and how to do it. These parameters are separated by commas. For the source, I'm going to use the close prices, and then put a comma, and then put 20 for the length. The output of this function is now an EMA on the close prices with a length of 20. But I actually need to output this function to something. We can't just have it sitting in the code. We need to set it equal to something that we can use in our code. To do that, we assign it to a variable. A variable is just something that stores whatever we set it equal to. If I set it equal to an EMA, then the variable is the EMA with those parameters. If that doesn't make sense, don't worry. This concept will become clearer as I use them more. You can name this anything you want, but I'm going to call it EMA1. So I'm going to write EMA1 and then set it equal to my function. Now, I have something in my code that is an EMA on the close prices with a length of 20 called EMA1. Let's plot this and see what it looks like. Just like we plotted the close prices before, I'm going to plot the EMA1 variable by writing plot parentheses and inside it EMA1. So just like this, plot, and then come up with our parentheses, and then just write our variable that we want to plot. And then if I update this on chart, It looks similar to the prices we had before, but smoother. This makes sense since we're just plotting the close prices, but with some smoothing from an EMA. Obviously, this alone isn't useful. You could have done this with the built-in EMA indicator, but we can do a lot more with this knowledge. In a minute, we'll look at some more advanced functions in the library and how to use them, but we can actually create a simple indicator with what we have already. With the variables that we create, we can do basic math with them, like adding, subtracting, multiplying, and dividing. I'm going to create a new variable called EMA2 with a length of 100. So let's remove this line that plots our first EMA. So EMA2 equals TA dot EMA, and then in the parentheses we have close, comma, 100. Now I have two EMAs we can use, one with a short length and one with a long length. Now if I subtract these two EMAs from each other, we actually get an oscillating indicator. So I'm going to take EMA1 minus EMA2, and since I want to store that value, I'm going to create a new variable called EMAdiff. EMAdiff equals EMA1 minus EMA2. And now I have a variable that is the difference between the two EMAs. Just like before, I'm going to plot this using the plot function. Plot, and then inside the parentheses, EMAdiff, and then update it on chart. And you can see this is starting to look like an indicator. It oscillates up and down with the price, possibly showing us turning points in the market. This is actually very similar to how a MACD indicator works, a very famous and popular indicator, and all we used is basic subtraction and an EMA function to create it. But you're going to want to be able to use more functions than just the EMA. Luckily, there's a function library we can look at that contains everything we need. We're going to use the Pinescript reference manual. I'll leave a link in the description for it. Once you're on the page, click Functions on the left, and then scroll down until you start seeing stuff that starts with TA dot. These are all the built-in TradingView functions we can use. You can click on each of them for more information, but you probably recognize a few, like the RSI, the Bollinger Bands, Supertrend, and others. You may notice some of these functions are not indicators, like TA.crossover or TA.change. These are functions that allow us to make more use of the other ones. We're going to see how to use a couple in our next indicator. For this next indicator, I'm going to create something that shows us the choppiness of the market. Being able to see how choppy or trending the market is behaving is a very important part of trading, and we can make an indicator to help us with just a few lines of code. Let's think of how we could do this. We want something that tells us when the market is crossing up and down without moving directionally much. If I put a simple moving average over the price, we get a reference for how much the market is moving up and down. If the price is continually crossing back and forth over the moving average, then it can't be moving heavily in one direction. What if we created an indicator that told us how long it's been since price crossed over the moving average? Let's do just that. Okay, so I'm going to erase everything we have before. And instead of putting the length of the moving average directly into the moving average function, I'm actually going to create a new variable called MA_length and set it to whatever length I want. You'll see in a minute why this is important. I want the moving average to have a length of 150, so I'm going to create a new variable called MA_length and set it equal to 150. This variable is a constant, which means it will always be equal to 150 and is completely interchangeable with anywhere we could put the number 150. Then we need our simple moving average. I'm going to call this variable moving average and set it equal to TA.SMA for simple moving average. And then inside the parentheses, our source, which is the close prices. And for length, I'm going to put the MA_length variable instead of a number directly. This is no different than writing 150 for the length here, since MA_length is equal to 150. Now we need something that can tell us when the price crosses over the moving average. Luckily, the TA.cross function does exactly that. I'm going to name our new variable crossMA for cross moving average and assign it to the new cross function. So crossMA equals TA.cross and parentheses. And you'll see we have two inputs for this function right here. Our two sources will be the close prices and the moving average. So we'll put close, comma, moving average. This function will return a true or false value. If the price is crossing over the moving average, the variable is equal to true on that bar. If the price is not crossing over the moving average, it will be equal to false. Okay, so now we know when the price is crossing over the moving average, but we want to know how long it's been since it's done that. This is where the bars since function comes in. Bar since does exactly what it sounds like. It tells us how many bars since something has been true. So I can create a new variable called in bars for the number of bars and set it equal to ta.barsince. In the parentheses, we have the option to put a condition in. Here is where we put something that can be true or false at different times. Remember how the cross-EMA variable gives us true or false? All we need to do is put the cross-EMA variable in the parentheses. Now, this in bars variable tells us how many bars it's been since cross-EMA has been equal to true. And for cross-EMA to be true, the close prices must be crossing over the moving average. To recap, the ta.cross function returns true when the two inputs are crossing each other, and returns false otherwise. The ta.barsince function tells us how long it's been since something has been true or false. So now we have an indicator that tells us how many bars ago the price crossed the moving average, and I can click Update on Chart to see the results. We get these large triangles when the market is trending or moving heavily, and many small triangles when the market is choppy. But what if I want to change the length of the indicator without going back in the code and continually updating it on the chart? Let's fix that. Going back to our EMA length variable, I'm going to remove the 150 and set it equal to input.int and create parentheses. The first value is the default value the indicator will be on when you apply it to the chart. I'm going to set it to 150 just like we had it set to before. And next, we need a title for this setting, so I'm going to write a comma to separate our parameters, and then, in quotes, just write length. If I update this on chart and open the indicator, you can now change the length to whatever you want. There's a few more important concepts we still need to cover. Let's do that by creating a momentum indicator, and as a bonus, we're going to learn how to color it like you saw in the thumbnail. For the base, I'm going to use the TSI, or True Strength Index indicator. There's a built-in function for that called ta.tsi. But first, I need to create the variables for the inputs to our indicator. The TSI has a short length and a long length as inputs, so the first variable will be short length. And like I showed you before, we're going to use the input.int function so we can change it in the indicator. So I'm going to write short length equals input.int, and in parentheses 5 for the default value, and then short length in quotes for the title. And for long length, we're going to write long length as our new variable and set it equal to input.int, and for the default value, we're going to use 10 for our long length, and we're just going to title it long length in the indicator. Now I can create my TSI. I'm going to call it True Strength Index and set it equal to ta.tsi, which is the TSI function. And for our parameters, you can see we need a source, a short length, and a long length. And the source is going to be our close prices, just like before. And for a short length, we can use our short length variable. And of course, our long length will be the long length variable. Now we have a TSI in our script. For this indicator, I want to use an EMA on the TSI line and use the crosses as signals. Instead of putting the close prices into the EMA function, I'm going to put the TSI into it. This will create an EMA of the TSI line. Since we need a length for the EMA, we'll create a new input variable called EMA length and set its default value to 50. So to do that, I'm going to come up here and just create my new variable called EMA length. And since we're going to want to change the input, I'm going to use input.int. And our default value will be 50, and our title can be EMA length. Now I want a variable that is an EMA of the TSI line, so I'll call it EMA TSI. And set it equal to ta.ema, and in the parentheses, I'm going to use True Strength Index for the source, instead of close like we were doing before. And the length parameter is, of course, EMA length. I can plot both of these outputs on the indicator. To do that, I'm going to write plot True Strength Index, and then come down here and just plot EMA TSI. This will plot both of these lines on the chart at the same time. But I actually want to add some color to the plots so we can tell them apart. To do that, I'm going to add a comma in our parentheses and then write color equals and then the word color and then dot whatever color we want. There's many colors built in, so if I want the TSI line to be gray, I would just write color.gray. I want to make the EMA line yellow, So I'll add a comma in the parentheses after EMA TSI and write color equals color.yellow. You can see the new, more colorful version. As a bonus, I'll show you how to fill in the colors between the lines with red and green depending on whether the lines are above or below each other. To do this, we'll use the fill function, so I'm going to write fill and then parentheses to put in our parameters. Since we need to fill in between the EMA and TSI line, we actually need to set the plots to a variable. We can do that very easily by writing TSA plot and then equals our plot function. And for the EMA plot, we can simply write EMA plot equals before all of our plotting. And now we have two variables we can put into the fill function. The first two inputs are going to be our two plot variables that we just created, TSI plot and EMA plot. Next, we want to conditionally color the fill in between the two plots. Don't worry too much about how this works or what this means. I'll go over it more in future videos. But for now, I want to write a statement that can be true or false. The statement will be true strength index is greater than EMA TSI. And then put a question mark. Like it's asking a question if the statement is true or not. Next, we put the color the fill will be if the statement is true. So I'll put color.green. And now write a colon and put the color it will be if the statement is false, which will be red in our case. So I'll write color.red. So we have a statement, a question mark, the color it will be if the statement is true, a colon, and then the color it will be if the statement is false. If you're trying this for your own indicator and getting the wrong colors, try switching the colors on either side of the colon or changing the greater than or less than sign until it looks how you want. Now, if I update this on chart, you can see it looks much better and easier to read. Just one more thing before I end the video. There's some functions you'll find that have more than one output. Like the EMA has one output, it's just the EMA line. But think of something like Bollinger Bands or Keltner channels. They have an upper, lower, and middle band in them. When you go to the indicator library for one of these types of functions, you'll see there's three outputs separated by commas and square brackets. This is how it is formatted in the script as well. For example, to create Keltner channels, I would have to write square bracket and then middle KC for the middle band, comma, upper KC for the upper band, and then lower KC for the lower band, and then set that equal to the function. They output the order they say in the function. This gives us three new variables named whatever you call them in the square brackets. So I would have three variables called middle KC, upper KC, and lower KC now created in my code. This would be the middle band, upper band, and lower band respectively. They output in the order they say in the function library, as in the first position in the square brackets will always output to the middle band, and the second the upper, and the last the lower, no matter what I name them in the code, and you can plot these just like normal. There are many ideas you can implement with these concepts, but realize there's still a lot more information. In future videos, I plan to talk about conditional statements, bar indexing, labels, overlay indicators, arrays, and much more. So remember to subscribe if you're interested in seeing more tutorials like this, or just seeing videos about indicators in general, without any of the programming. I still make those too. And if you really enjoyed this video or found it helpful, a like would be greatly appreciated. I'll see you in the next one.